thought a math term would you say that's a lot.
Can I look at my notes?
Dispersing, right? Dispersing, so it's spreading out. Ooh.
Wouldn't dispersing mean it leaves and not spreads?
Huh?
Or no.
Dispersing means it's spreading out, and it's not just spreading out, but it's evenly like taking up. So now the space between the blue food coloring and all the water is equal, so it's evenly dispersed.
Nice.
Same with the salt in here now. It's evenly dispersed. It's all mixed up. Does anybody know what the word is whenever you put something in water and you dissolve it completely and you can no longer tell the difference between the salt and water?
Chemical reaction?
Nope, there was no chemical reaction. We know what it's called? I have a liquid now that I cannot tell the difference, but it looks the same all throughout. I can't tell where the salt is and where the water is. It looks like one thing. Everybody know what that word is?
Are we going to use for the coloring with this one too?
Looks like it starts with an S.
No.
Solution.
I heard about it.
So I have a solution. Why don't you come back over here? I have a solution because I have a liquid that I've dissolved something in, and you can no longer tell the difference between the salt and water. It's all mixed in perfectly, so I have a solution. And this is also a solution too because of the food coloring. All right. What makes these two things different? Now, a kindergartner could easily tell me what?
That one's got salt color.
They're different colors.
One salt water.
One is salt water. We're not kindergartners, and we are smarter than kindergartners. So I've already told you one thing about these, is that they are the same temperature. So that's like a scientific term, temperature. What's something else that is different, other than their color, other than that it's salt water and fresh water? What is different about this salt water and this fresh water? The mass. Mass is a science term we've talked about, right? Which one would have more mass? Who thinks this one has more mass?
No, they don't.
Does it have more? Mass is the measure of the amount of matter in an object. Does this have more matter in it than this one?
Yeah.
This one's made of what?
Liquid.
Water. And this one had water in it, and then I added matter.
And you made
I added salt. So
Oh,
this
I
one,
made it right.
well, it didn't make any. It lifted the. You're right. Raised the.
So it is mass because it fills up the space.
That's right. So mass. This one has more stuff in it. So this one has greater mass.
This one's denser.
Okay, this one is more dense.
And it's harder to see through.
Okay, so this one is more dense because it's taking up the same place, the amount of space. So the amount of matter per volume is density. I have more stuff in here, but it's in the same container. So this one is taking up the same amount of space, but there's more stuff in it. So that means everything in here is more compact, it's more dense. Right? This one is water with salt trapped in between those water molecules. This one's just water.
Are we going to use another color for the salt one?
No.
Oh.
It's blue and white.
Man. If you added a red one, we could put red. If we added another one, we could put red in it.
We could, but let's focus. I got salt water, which means it is more dense. It has more mass. Is there anything else y'all can think of? Makes them different.
Taste it.
They would taste different.
Will they have taste?
You ever tasted salt water before?
This one would taste salty. This one would taste like not salty water.
Just like blue water.
Tastes like blue water. Anything else? Density is the one I wanted you guys to get, so we're good with the density. Okay. What would happen? You got one more?
This one would freeze at a lower temperature than that one.
At a lower temperature, the salt would make it freeze faster?
No, at a higher.
No. There's a certain type of salt that makes it freeze faster.
You would have to, this one would have to be at a lower temperature. You're right. This one would have to be colder. You're right. So this one would have a lower freezing point. Good job.
I learned about that over 5 years ago.
Yeah, make it freeze faster to put it in there.
Salt does a lot of really neat things to freezing temperature. All right, focusing on this. All right, what would happen if I put the blue water, the blue jar full of water, and I could gently set it on top without the mixing? Okay, like I put this in between it. That's what I'm gonna do. And I set it on between. Set on top with this in between, and I move it. What would happen to the blue water? Lewis, are you on your phone?
No, he asked me to do My phone is like cracking.
So yes. Huh?
Yeah, I was on it.
Go put it in the caddy. Alright, so what would happen if I take this blue jar, I set it on top of this salt water, and then I remove this so that they are in contact? What would happen? This is more dense or less dense?
Less dense.
And this is more dense. So what would happen to this whenever I do that?
It wouldn't mix.
It would not mix. What do y'all think?
I think it would mix a
Oh, you're
little.
talking like on the lids of them or on the bottom of them?
I'm going to take this, I'm going to flip it upside down and put it on top.
Oh.
Is that wax paper?
And then I'm going to remove this. What would happen whenever I remove it? He says they're not going to mix. They're just going to stay
They're gonna
stable.
repel each other.
They're going to repel each other, so they won't mix.
Hey, if you
I don't know.
hey, that's actually a really
Do
good
you guys think
idea.
this would stay on top, or do you think it would mix or sink to the bottom?
It's gonna,
Stop.
it's gonna stay on top.
Stay on top.
That's it.
Why is this going to stay on top? It will, but why?
Oh, it's right.
Because the salt and
Because the different densities contrast each other.
There's a difference in densities, so the things that are less dense will float or rise. Yeah. All right, let's see if it happens. Without me making a big old mess.
it's not gonna work at all. Oh wait.
Nice. Oh dear.
Wouldn't it make more sense to slide it to the center of the middle?
That's no.
All right. So we're saying that this is going to stay on top because it's less dense,
Mhm.
and this is going to stay on the bottom because it's more dense. Right? Yes. No.
No.
I was like, oh
It's
no,
good.
it's going to happen. Let's see what happens.
Switch. Just keep switching.
For the most part, they were right.
For the most part, they did not mix. All right. So let's observe.
Look, you can see the waves moving around.
So let's observe. Let's let our brains think a little bit, and then we'll make some conclusions. I told you this was not going to be very exciting. Nothing happened.
It smells like laundry detergent.
I got a question.
Smells like water zero.
Will there be a point of time where, like, let's say it was like this for a whole week, would it all be together, or would it still be like that?
All right, that is a good question. That is a good question. So let's all try to do this one thing at a time and stay as a group like we are right now. He said, if I leave this for a long period of time, will it eventually mix? What is the reason that they're not mixing? Because of the density. So you're saying over time, will the density change? What would have to happen in order for the density to change? I'd have to add some energy to it. Like if I shook it up, that could cause some mixing. If it started to leak somehow, as I said, it shouldn't. It shouldn't mix because there's no reason for this more dense water to rise. It wants to stay there. So it shouldn't.
So we're talking about a sentient thing.
That's what we're going to do next.
Oh, so what
Okay.
about Kool-Aid? Would I do that?
As long as there's a difference in density. As long as you have like Kool-Aid and salt water. Like that would be a good like prank. Like if you can get it to whatever, you could drink salt Kool-Aid. Anyway.
Thanks for the idea.
Try that.
All right. So Hatfield said, as long as I don't add any energy to it, it should stay separated, right? So I'm going to try to flip this over. So I'm going to add just a little bit of energy, but I'm going to try to keep it a stable system. I'm going to try to keep this system stable. There will be no mixing. Everything will stay separated. If you,
Would it be easier
I would
to
just
put
tape
a
it.
tape on that?
Yeah.
it just takes away all of the risk, you know?
Yeah. What happens if you pour it out?
So let's also pretend like this could be like two different bodies of water. You could have salt water, ocean water, fresh water from like a lake or a river.
So
As long as there's not a lot of energy, then the fresh water and salt water would stay separated. But when a river flows into the ocean, that has a lot of energy with it, so they mix. But if there's ever time where those two bodies of water meet and there's not a lot of energy, they would stay separated. We also think of this as like the atmosphere. The atmosphere moves like a fluid, even though it's a gas. So if I have a massive air bubble of air that is less dense, and then a massive air bubble of air that is more dense, they wouldn't mix. What kind of air is less dense?